Morning, let's get going. Thanks for coming. I've been a professor of earth sciences and geology at this university for some 23, 24 years now. And as part of the courses that I teach, 100, 200 level courses, which are my greatest joy, I have the dubious pleasure of dealing with the origin of life and evolution of life, which is part of, obviously, of the story of Earth. And I've given this a somewhat ambivalent title here, and you see this gentleman there is quite typical for creationists when you get to talk to them. And I have about 1 or 2 out of 100 every year in my courses. So I have to deal with these people one way or the other, and I will show you how I have chosen to deal with these kinds of people. So many of them just close their eyes and they don't want to hear anything other than what they've been taught in, well, kindergarten and grade school, and you'll see how that all fits in. We've had traditionally over the last, let's say, 200 years, we had courses all over the world that were called something like historical geology. The historical geology as such that we had at this department here at the university doesn't exist anymore, and actually I don't teach this course anymore because everything's got remodeled. But that said, the core of what I'm about to show you, I'm still teaching in various other courses, in 2 courses, basically introductory courses for the Faculty of Science. So this is not just geologists, this is Faculty of Science, it's a service course or 2 service courses. And I do skepticism and have done skepticism for as long as I've been a university teacher. And the first part, number 1, is what I'm going to spend the first 5 minutes on, is of course a generic topic for the entire, well, certainly the Faculty of Sciences, not just for earth sciences. And the second is 1 out of maybe 8 or so, 10 different topics that I'm covering, and I'll use this, the creationism versus evolution debate, I'll use this basically as an example. So let me, and it takes about 2.5 weeks, or took about 2.5 weeks as long as I was teaching this course, so I'll compress this into maybe 20 minutes this morning, okay? So the scientific method is a thing that I think everyone standing off. Unfortunately, our society is, by my standards anyway, more or less scientifically illiterate. And that is why I teach scientific literacy, or literacy, whatever you want to call it. So in a nutshell, for those of you who are not quite familiar, perhaps with a flow diagram like this is sort of the philosophical notion of deductive versus inductive reasoning compressed into 1 page, for those of you who study philosophy. So somebody makes a claim, or in science we call this a hypothesis, such as the previous speaker had an example, there was a UFO, right? Or the Earth is only 4,000 years old. Any variety of claims you can think of. Then we test this claim. In science we call this an evaluation, and there's various ways of doing this. You can gather field data, as in standing up on a building and taking whatever optical instruments you have and recording things and you name it. Or you can make lab experiments, which is done in physics most of the time, or you can calculate things if it's neither field or lab suitable. And then you wind up with 1 of 2 possibilities. Either you validate the claim or you invalidate the claim. There's a few soft rules in science that I also teach the students as we go along. I tell them what Occam's razor is. I tell them that, this is a little pale, I'm sorry, I can't read this. Correlation is not the same as causation. This is what it says up there in that little blue box. It looks good on my screen. And there's such a thing as convergence of evidence. I don't have time to explain all that this morning, but bear with me. This is part of the package. And then you wind up with this fundamental result. A hypothesis or claim of any sort, supported by many rigorous evaluations or tests, and not invalidated by a single one, becomes what we call in science a theory. So notice it is awfully easy to shoot down a claim because you need only 1 single test or evaluation that invalidates it. It's awfully hard to prove something because you have to have many tests and they have to be rigorous, and then you have to make a judgment call, do I have enough tests and all that, okay? We call it a theory, and this is really bad. This is bad semantics, but that's what we have to live with. And it leads to things like, oh, evolution, that's just a theory. Why? Because theory in colloquialism means something vague, something that is not really proven. Unfortunately, in science, this word means the exact opposite. So for colloquial language, we call this a fact, or it's true, or it's reality. But this is part of the problem we have with this whole creationism evolution debate, is the semantic problem of what a theory means in science. So here are examples that I cover in my courses of theories that are proven beyond any reasonable doubt. The atomic theory, the theory of relativity, the theory of plate tectonics, and yes, the theory of evolution. And I'll show you a little bit of that as we go along. I also cover examples of theories or claims that are bunk. 3 examples are crystal healing or crystal power. And if we have enough time after the lunch break, I'll give you another talk on that. Astrology or water dowsing. These are all things I cover, and if you want to have some fun, come to my courses. And then I have devised what I call a field guide to critical thinking and evidential reasoning. This is something I hand out to my students. It's also posted online. You're welcome to download this thing. And I go through some 8 criteria, such as falsifiability, logic, comprehensiveness, sufficiency, and honesty, all of that. I don't have time to do this. Feel free to download this page. The one single page, or rather the one single point I want to alert you to is this one, and I've already mentioned. If a claim is valid, then must not be a single argument or piece of evidence that falsifies it. All right, so now let's use that mental framework, philosophical framework, and apply it to this whole creation-evolution debate. Now, of course, I could just ignore creationism, as most of my colleagues do in neurosciences, but I've chosen to actually give this coverage. I wouldn't say equal weight, but at least coverage, and you'll see in a moment why. It's a political as much as a social criterion. So the creation side of the story, it's a doctrine in a philosophical sense, says basically that all life was created as stated in the Bible, and then you read a bit of the Bible, and then you know how that's supposed to happen, and there's no evolution, as in biological evolution. And of course, on the other side, we have the theory of evolution, and you know now what theory means. Life originated from lifeless chemicals in some form that is very much debatable, but then that is not nearly as debatable. We have first primitive life forms, such as microbes of various types, that evolve into more complex life forms. So again, is this even a debate? Here's an article that I'd like to alert you to from 2004, not too long, from the Sunday Times, where I found a very interesting quote by a former American president. In 1922, just after his second term as US president, Woodrow Wilson was asked for his thoughts on evolution. Of course, he said, like every other man of intelligence and education, I do believe in organic evolution. It surprises me that at this late date, such questions should be raised. That was 1922. More than 8 decades later, it says here, the state education superintendent for Georgia, and it happened in other states, in Kentucky and Tennessee, is now proposing that the word evolution be banned from school biology classes and textbooks to appease biblical fundamentalists. Which brings me to this chart, which is downloadable on the internet, that I highly recommend you look at. It was published in 2006 in an article in Science. I call this the chart of enlightenment, or less flatteringly, a chart of intellectual retardation. And it compares, this is of course surveys in countries, 34 countries in this case. It compares the number of people who are, subscribing to the theory of evolution as a scientific theory, or fact, if you like, versus those who don't, and those who don't really know. And at the top of this chart, there's the biologists and geologists, and you can put me into this category. Blue means the evolutionists. All right, pretty much all of us who have any intelligence and knowledge about the subject are evolutionists. You will find maybe 1 in 10,000 who's not. And then you see it goes down, so we have Denmark. For some reason, some of the words here are not legible, but I can show you. Ireland is at the top, and then comes Denmark, and then comes Sweden, and France, and Japan, and other European countries. And you see they have sort of an acceptance of the theory of evolution from 80 to 80 or 79, 78, 7, and so forth, right? So pretty much all industrialized countries are there with a long, long blue bar. But right at the bottom, second from the bottom, you have the United States of America with only about 40% of the general population out of 340 million people. Only about 40% actually believe in the theory of evolution or accept it. And Alberta is right there. Alberta is exactly on par with basically the, well, I would call it less flatteringly, intellectual retardation. That's not a term I use in my class, I might add, but I'm using it in today's context, okay? And don't you think this is a new phenomenon? Oh no, by a long shot, it isn't. This is from an article in National Geographic 2004. And again, I'm blowing up this paragraph that is relevant here. Gallup interviewers posed exactly the same choices in 1982, 93, 97, 99. And the creationist conviction that God alone and not evolution produced humans has never drawn less than 44%.